All right, this is going to be the supplemental training for the PCB Mill in the design lab. The first thing we're going to do is open up the application, the PH CNC 64. All right, when that opens, first thing we're going to want to do is import our Gerber files. You can also do DXF files as well, but most of the time you're going to have Gerber files, so we're going to stick with that. Then you can just select the file or the folder that your Gerber files are in. And this is how you import them. We're going to designate like the top layer and the bottom layer, the drills, and then the mechanical layer. So the way we do that is we're going to click on the Gerber file, and then you can see over here we have choices of to designate it for the top, bottom, mechanical, and the stencil top, stencil bottom. So this is the top layer, so we're just going to click on the top. You can see it pops up down here. We're going to do the bottom layer. Next thing we're going to do is the drills. Thing about the drills is that they need to be in the top layer. Since we're going to, when we flip it over to do the bottom layer, we'll need to locate those holes to be able to line everything up. So those holes need to be drilled in the top layer. Whenever we do select the top, this page is going to pop up. We're not going to mess with this right now. This is designating the hole size with the drill. We're going to worry about tool selection all together later on. So we're just going to do auto detect and then hit OK. And you can see they popped up right there. If for some reason they're not in the location, sometimes you might have to go back and actually change, what hole we have. But we're not going to do that here. So we should auto detect. Okay. There we go. All right, last thing we need is the mechanical layer, which is the cutout. So it's going to be the profile, mechanical. Looks good, so we're going to go ahead and hit import. You see it popped up. But we're going to move it around. It can be about over here. So what we're going to do that is have to go up here to select, move, clone, delete objects. Select it all. We're going to right click on it. We're going to come down to move to. If we have a coordinate, we can put in the coordinates, it'll move, or we can just hit move and click and drag. Yeah, that's about where I need it. So I'm going to hit escape. So we want our file to look like this PCB over here. It's our end goal. So we can see that this blue line is what is left over, the copper that's left over. This green line is where the tool path is. So the tool is going to come in and actually cut along this line. For the bottom layer, the line that's left over is red, and the blue is what's being cut away. And then for the mechanical layer, this big brown line is what the tool path is. So I actually need to designate the tools that are used to cut this out. And the first thing we're going to do is the insulate layers, which is the blue lines and the red lines. So we're ready to do that. We're going to come over here to insulate. So again, this is where we actually get to select the tools that we used. The PCB Mill has an automatic tool changer. So these tools here, the TH02, that's tool 2, it's tool 3, tool 9, tool 11. These are ones that are already programmed in. And if you select it, it automatically changes the tool over. If you have your own tool, you can do a manual tool change. And that's in the manual, goes over how to do that. But we're going to stick to the tools that are in the automatic tool changer. So it's already selected tool 3 for us, which I think will work out just fine. When you click on the tool, you get all the parameters over here. But let's just say that I wanted the line to be thicker. So I wanted to remove more material. I could come over here and you see how the diameter of this one is 15 millimeters versus 5, the one that we have selected. So if I wanted to just see how that would look, I could come over here and select tool 9, hit OK. And you can see that we're removing a lot more material. But you can also see that there's a different color in these corners. That's because this tool, the larger tool, can't get in that corner like that. But since we still had tool 3 selected, it's actually going to come through with the larger tool first, machine all this, and then it's kind of going to come in with the smaller tool and machine these corners. So, but if I didn't want those corners to be machined, I could just unclick tool 3, hit OK, and you can see that this corner is just going to have this radius. He's not going to come in here and machine this. So it's just something to watch out for, because something like this could become a problem. We want this line to look like this. It's not going to. So we're going to keep this like this. We're going to have the larger tool come in here and machine the more of the material, and then have the smaller tool just get the corners. So our next layer is the cut. That's the perimeter, the mechanical layer. This one doesn't really need to change. It's literally just cutting out this outside. So if we changed the tool, nothing different would happen. So if you hit OK, the rub out tools. So we don't have any rub out right now. Let's go ahead and add some. So the rub out is taking out a large section of material. The way that we put that in is over here to select rub out region. We're actually going to select the area that we want to be removed. So I'm going to do this section right here. And then you can click on process rub out, and it's actually going to remove the material. So we processed our rub out, and as we can see, we've got a large area that's being removed. And then we are coming in with another tool to get these corners. We've actually got, looks like 3 tools that are selected. Let's find out. So we're going to go over here to rub out tools, and we do have 3 tools that are selected. Something to keep in mind that if you have a large section that's being machined, you don't want to do that with a small tool. You want to do that with a larger tool. So what's happening here is it looks like we're getting the corners with the V-bit, and then we're going to the larger, the 62.5 mil end mill, and then we're coming in with the 15. So the 62 is going to remove the bulk of the material, and then the 15 is going to come in here and get the corners that the 62 can't, and then the V-bit is coming in and getting the tiny corners. The larger tool is going to remove more material. So this looks good. I don't think that we could improve too much. We could use the 125. Let's just see how that looks if we do. Yeah, not much different. We'll go ahead and just keep that selected. All right, so we've got the rub out, we've got our mechanical layer, and we've got the insulating layers. Now let's do the drills. So something interesting about the drills is that we may not have the right drill bit to actually drill the hole as the correct size, but we're going to hopefully get as close as we can. So we've got the drill tool table selected. And what this is telling us here is the hole size, and now we have to select a tool to correspond with that. So it's going to know that, hey, every time that there's a hole this size, I'm using this drill bit. So we're going to select on that, and this is where we get to select which tool is actually used. So our hole is 0.0327. We do not have a drill that is 0.0327. We do have one that is 0.031, and we have one that's 0.036. So we can make a decision whether we want the hole to be smaller than it should be or larger than it should be. It's totally up to you, or if the hole size is critical, you can always bring in your own drill that is for this machine and do a manual tool change. I think I'm going to select undersize though. I don't think I want to do 0.036. I want the 0.031. So I'm going to select that. And you can see that the number 1 changed to tool 5. So every time there's a hole that's this size, it's going to go tool 5. And you can actually see that this is the diameter that's actually going to be. You'll also see here in a second that this red project tools is going to go blue. That means that we're good. It was red because we had a hole that didn't have a corresponding drill size. So if the program were to run, it would come up to these holes and wouldn't know what to do because we didn't tell it, hey, select this drill bit when you come to this hole. All right, we've got our tools assigned and we're almost ready to go to the CNC side. But first we need to add breakout tabs to here. So right now, when this is cut out, all it's going to do is it's just going to cut it out, which means that when it gets cut out, this thing is going to go flying. So what we want to do is add what's called the breakout tabs. The way we do that is we come up here to Edit Mechanical Layer. When we hit that, you'll see that this white line pops up. This white line is the inside of the cutting line, which can be selected. So right now, the white line is telling us that it's not the one that's going to be cut. If you click on that, then both of these are brown. This is actually going to cut both of these lines. This is not what we want. Now, if you wanted to cut the inside line, you could select the inside and then click on the outside line again. This means that it's just going to cut on the inside. But you can see if that happened, we'd be cutting on our insulate line, which is not what we want. We want the outside line, so we're going to click it. Just be aware of that. So what we're going to do is add breakout tabs to make sure that when this is cut out, it's still here. And the tabs are small. You can just bend the PCB and break the tab off. So we're going to do one here and then over here. So you're going to right click on the line, come down to breakout tab, hit insert, and there you can see that there you get a tab right there. If you want to change the size, you just right click on the tab, go down to breakout tab, setup, and you can change the thickness. 20 mil usually works pretty good for me. I can actually just bend the tab a little bit and it'll break right off, or take a pair of pliers and just bend it a little bit. And we're gonna do the same thing over here on this side. We're gonna right click, breakout tab, insert. So what's gonna happen is the tool's going to go into the material, start cutting. When we reach this here, it's going to raise up in the Z, move over, and then go down back to start cutting, and do the same thing over here. So this makes sure that the part is not going to go flying whenever it's done being cut out. So once we're good in that, we can exit out of Edit Mechanical Layer, and we can go to CNC. All right, when we click on the CNC application, we are going to see this pop up. It says machine in emergency stop mode. Essentially means that the machine is not homed. It doesn't know exactly where it's at. So we are going to home it. When we do that is we're going to hit emergency stop, and it's going to say that the machine is not homed. Would you like to home the machine? Yes, we would like to home the machine. Once we've done that, we can actually start machining. Now, the good part about using the tools that are in the automatic tool changer is that you can just run the program. You don't have to worry about changing tools or what's going on, but we are going to select the top. And the way that we do that is we're going to come up here and we can do we have the option to do the entire top, just the installation of the top, the rub out, the drill, or we can come down to the bottom layer. We want to do the entire top. Since we have our tools in the automatic tool changer, we can just run the entire thing. Or we can come down here and I can say, hey, I don't want you to do the rub out. Or I can say, hey, I don't want you to do the drills. And it's just going to do the installation. But we want all of them to be done. So we're going to select all of them. And when we have that, we can just come up here to go. It's going to ask to home the machine again. We say yes. It's going to move over and home the Z so it knows where the material is at. And it's going to start running the program. All right, so now that we've machined our top layer, we need to machine our bottom layer. So first thing we're going to want to do is come over here to Program and come down to Entire Bottom, and you'll actually see that PCB is flipped over. I did that because we actually need to flip the material over. So we're going to flip it over along the x-axis, and we need to locate the PCB. The way that we do that is with the holes that we drilled. So if we hadn't drilled those holes in the top layer, we wouldn't be able to have anything to locate for the bottom layer. So you can see that this rub out region, which is at the bottom, is now at the top. So when we have our material flipped over and we have the PCB flipped over the program, we need to locate where these holes are at. And how we're gonna do that is come over here to Chase Mouse. And we want to move the camera over to where we're on top of the material. And we want to hit autofocus. We want to go ahead and focus this camera. All right, the camera is focused. Now we can right click and let's go to visual registration mode. Now what we want to do is locate where one of our holes is at. We're going to try to find this lower left hand corner. I've actually put a piece of tape down that's close to it so that I can find the tape and then I can find the hole, just to make it a little bit easier. So I'm going to come over, down, all right, there's the piece of tape. There's the hole. So you can see that this is where the hole is actually at. This is where the program thinks it's at. So what we want to do is find the center of this hole and line up these crosshairs to that center. What we can do is right click, come down to auto hole detector, and it's going to tell you where the center of that hole is at. Right click again, come down to move to hole center. Now we can be pretty confident that that is in the center of the hole. Now we want to come down to the hole that it needs to be. So we need to identify this hole with that hole. And we're going to come over here. We're going to right click. And we're going to say move to camera position, fiducial point 1. Now the PCB was moved up to where that hole is at. Now we've done one, we need to do another one because right now we know where its position is at, but we don't know the rotation. So what we're going to do is we're going to find this hole over here. We're going to want the one that's diagonal. This one's a little bit easier to find since it should be close to that general area. So we're going to move over and up. Same thing, we're going to right click. Right click, we're going to say move to hole center. You see it's off rotation just a little bit. So this is where the crosshairs of the program PCB is, and this is where the actual hole is. So we're going to right click on those crosshairs and we are going to say move or rotate to camera position, finisher point 2. And it's rotated it. You can see that it's not exactly spot on, but this is such a small amount that it is as close as it's going to get. And you can see that it actually rotated a little bit. So now that we have the position of the PCB, we can come and actually machine the bottom layer. We put in the rub out section earlier, but we only want that for the top layer. The rub out section is not associated with any layer, so we could have done it, we could have not done it in the top, and we could have only done it in the bottom, but we just wanted to be done in the top. For this PCB, your PCB might be different. So we're going to unselect the rub out. And so now it's just going to do installation, and it's just going to cut it out. It's not going to machine the rub out. So now we can run this program.